Last lesson we added and subtracted radical expression or radicals, and in this lesson we're going to multiply radicals. This is lesson 9.4, and multiplying radicals involves the use of a property. It's the product property of square roots. And what this property tells us, if I have the square root of a and I multiply it by the square root of b, gives me the square root of ab. Likewise, if I have the square root of ab, I can take it apart and it's the square root of a times the square root of b. When we're multiplying radicals, we're using this first part of this property. So unlike adding and subtracting, the radicals don't have to match. We multiply the terms underneath the radical. If there are terms outside of the radical, we multiply those together. And then we simplify the radical. So for example, if I had the square root of 6 times the square root of 3, what I would do is multiply the 6 times the 3, and that would give me the square root of 18. Now the square root of 18 can be simplified because that's 2 times 9, and 9 is a perfect square of 3 times 3. So my final answer would be 3 times the square root of 2. If I have a term outside of the radical, for example, 2 times the square root of 5 and 3 times the square root of 15, I'm going to multiply the 2 and the 3, and I'm going to multiply the 5 and the 15. So I multiply things that are alike with each other. And I'm going to get 6 times the square root of 75. Now we've simplified 75 in our last lesson, and that's going to be 5 times the square root of 3, but there's already this 6 out front. It does not go away. So my final answer on this would be 30 times the square root of 3. If there are variables involved, we would multiply those together as well. So for example, if I have x to the 5th times x to the 3rd, when I multiply exponents, I add them. So I would get x to the 8th, and then simplifying this, I would get x to the 4th. If there are number portions underneath the radical, we multiply the number portions together, and then we multiply the variable portions together. So this would give me 2 times 10, which is 20, x to the 3rd times x squared is x to the 5th. Then I simplify. 20 is 2 times 10, which was 2 times 5, which gives me a 2 to bring out. And 5 divided by 2 is 2 with 1 left over. So this would give me 2x squared times the square root of 5x. And this is how we would simplify or multiply radicals. And how to multiply radicals, we can apply that to multiplying radical binomials. We use the FOIL method to do this. So for example, if I have the square root of 2 minus the square root of 5, and I multiply that by the square root of 6 plus the square root of 20. I'm going to do FOIL, so I'll do first. That gives me the square root of 12. Should make that a little lower. Square root of 12. Outside gives me the square root of 40. Inside gives me minus the square root of 30. And last gives me minus the square root of 100. Now I'll simplify each of these and see if any of them match. This is 3 times 4, 4 times 10, 2 times 15, and then 10 times 10. So I do have a perfect square in the 4. The square root of 30 won't reduce, but the square root of 100 reduces to 10, and none of these actually gave me any kind of matching radicals, so I could not simplify it any further. Let's try one more. Right now we have a difference, sum and difference. If I do the square root of 6 times the square root of 6, I get the square root of 36. I do the square root of 6 times negative the square root of 5, and that gives me minus the square root of 30. I do the square root of 6 plus the square root of 5, and that gives me plus the square root of 30. And then I do the square root of 5 times minus the square root of 5, and that gives me minus the square root of 25. This is a perfect square. These two terms cancel each other out, and then I have a perfect square, so I have 6 minus 5, so my final answer is 1.